This conference will now be recorded.
My chat.
This conference will now be recorded.
Hello guys. I hope you are all able to hear me. So this is a DevOps course. This is a DevOps Essential DevOps Foundation course. In this, I'm going to cover Git, Jenkins, Ansible, Docker, Kubernetes. So these are the 5 different topics which I would like to deliver in this course. So it is going to cover approximately 35 hours. So this may extend, this may takes much time. I'm not sure exactly 35, but it is estimated as 35. So to work on this, we need a little bit basic awareness of Linux, Unix, and basic SSH connectivity. You should aware of that. And VI editor or VIM editor or any Unix based editor, if you are aware, that would be the basic prerequisite for this course. So in this learning rules, DevOps, the experiments, whatever we are going to carry out, that would work on Amazon Web Services or Azure Cloud, any cloud you can take, and not only these two. You can also go with the GCP, you can also go with the DigitalOcean. Each platform is having the different scenarios to log in and then get the instance from out of that. Once you get the instance, the same story that will be, we are going to work on one of the Linux instance. So most probably we are working on CentOS or Ubuntu. These are the two preferable Linux operating systems which we are going to use, where we need basic shell scripting capabilities like sometimes you want to do repeated tasks and that will be pushing into one small script, and then we are going to make that as a shell script. So making this session more interactive, I would like to hear from you guys more questions, more practice, and whatever we are doing, I'm always sharing the every day task in the GitHub. And also I'm having one Google Drive specially dedicated for this course, so where I'm going to place all the presentations and hands-on material there. And if you want some help, so we are going to make WhatsApp group. So if you have any urgent issues, so that we can share across our group and anyone can respond on it. So I'm also responding whenever I have the free time in that. So you can also remind me whenever I start the session and I'm going to start with the flow. So please remind me when I'm starting record that session. And always I want feedback from you guys if it is good or bad, and to let me know so that I can always ready to accept and improvise better and deliver next time, get more. And if you miss something, we will get completed with that one. And we have another option for alternative to the cloud, that is virtualization. So we can also work with the virtualization concepts with the two different softwares, which very easy to handle from your laptop itself. So I refer Vagrant and Oracle VirtualBox. These two will help us to make the squeezed boxes or small size of images, Linux boxes. And if you want to work with a couple of clustering concepts or master slave concepts, sometimes we may need one or two or three virtual machines need to be created on your machine. So some of the experiments which require 1 GB or 1.5 GB for each virtual box. So how do we configure that? What are the requirements that we'll discuss in later sessions? But at the moment, we can make the virtualization labs using the Vagrant and Oracle VirtualBox. Okay, I prefer to use the Oracle VirtualBox. There is alternative is also there, VMware. Okay, yeah. So the first topic is about the Git. The source control management, which we are going to have most common in DevOps. The second topic is continuous integration with the Jenkins. The third one is Docker, and we are going to learn about the DevOps culture. We'll talk about this in detail in today's session. And later on Docker learnings, then we will move to the Kubernetes, where we are going to have the cluster of the containerization. The configuration management, where we are going to have the most common tool, that is Ansible, or most uprising the tool. So these are the topics which are already shared with you in the WhatsApp. The same content is here on this screen. So don't worry about this, what is it contains and what all those things. So totally it is 6 modules, and today we are going to see what is the overview of DevOps. So anything you want to speak out on this? Any questions from your end? Guys, are you with me?
Yeah, that's fine.
Okay, what is, how it will help for a DBAs, and that we would like to know.
If no questions, moving forward, the key takeaway from this course, we are going to have the CI/CD, Jenkins, configuration management with Ansible, and some of the applications we might run on the Tomcat. And AWS is a cloud, which is most preferable option cloud. Another one is Azure. Vibrant VirtualBox virtualization concepts we'll discuss, and monitoring tools, some of the solutions we'll discuss in this foundation course. And the most important thing is Docker and Kubernetes. Docker containerization will talk in detail, and the containers move into the cluster with the help of Kubernetes. The complete understanding and build configurations of the small size of microservices application. Now the trend is moving towards the microservices, where our applications also test with the small use cases, where how the microservice will be built, how that would be deployed with the help of Java programming language that is developed with Java, and that could be deployed on targeted application servers. And experiencing the integrating of this static and dynamic code analysis, and whenever you are working on the build pipelines, so most of the DevOps engineers are expected to work on the Git or GitLab. So there is a need of building the pipeline and create the jobs, and that should be executed, and they should able to troubleshoot why it is failed, what is the problem, and all those things we'll try to experience in the course. So we also understand the cross functionality, understand the agile and scrum strategies, how it is going to work in projects. So overall, that is what is DevOps Foundation, DevOps Essential course, what we have defined in this. Okay, for today's demo, DevOps, whenever you look at the DevOps icon, it is a big infinity symbol. That infinity symbol indicates that it is a continuous process. It starts from the right side, left side part, and it will go on towards the right side. So developer develops, and operations will be taken care by the operators. So developers always look for they want maximum changes, and whereas operators, the administrators, earlier they are called, so operators won't always optimize the stable versions they want on the production. So that is in between these two, the development and operations are together to form one single team, that is DevOps team, and they want to build code, plan, and release. Once it is released, deployed, and operate and monitored, then it will be repeated the task, and it is continuously flowing between these two circles only. So it is not never ending, it is continuous, and it is what the infinity symbol indicates that. Okay. So myself, Bhavani Shekhar, I have a MCA and MCA from the Osmania University, and I've worked around 15 years into this IT industry. I'm also having experience in middleware technologies, WebLogic administration, build and release engineering, continuous integration tools like Jenkins and Hudson, continuous delivery and GitLab. I worked on. I'm also working on the Docker and Kubernetes cluster and many automations like scripting, shell scripting, Python, Jython. These are all my experience areas. So today's demo agenda is we are going to talk about the evolution of the DevOps. Why DevOps is important in the current trending IT, and what is actually DevOps? What are the tools DevOps? And then we talk what is not DevOps so that we can get clarity. And what is the scope of DevOps in the current market, job market, and requirements in current trend. So these are the major things which we are going to cover in this session. So evolution of the DevOps. So before DevOps, what was there? So if you look at the first, the largest, longest time, which was their waterfall methodology. So it is based on sequence of starting with the requirement phase and where 100% of the system is completely under development was defined up front. So it is completely planned and everything will be done one by one phase after the another phase. So one phase completes, then another phase will go enter into that one. So it takes longer time. So there was no option to go back to that phase, previous phase. So that is a disadvantage in the waterfall model. So to look into the alternative options, there is a new methodologies also came up, and a lot of different methodologies are evolved and gone out. So out of that, lean methodology was developed by the Toyota in 1990s. So in 1990s, they developed Tata Motors. So sorry, Toyota Motors. They developed especially for their productivity. So this methodology was introduced to remove the unnecessary options from the system. So the system, what they are producing, how they are going to deliver the entire system from the beginning of the each nut and bolts screws. From there, it is going to the complete car. How much time it is taking? They have evolved. They started looking into that part, and they started looking into what is unnecessary thing, which is taking the longer time. So how to avoid that part? So this is what the lean methodology plan. So that is there successfully implemented, and the same thing is adopted to the IT. So removing unnecessary software features and communication delays, slow application response times. These are the things targeted using the lean methodology. So if you look at the Vagrant, if you look at the Docker containerization concept, so all these are focused with the same methodology. So if you look at the Vagrant box, if I just take the one simple example, CentOS operating system, if you are going to install, it is going to take 1.6 sorry, it is going to have the entire CD disk ISO image itself 6 GB size. If I'm going to take Vagrant box, it will be in MBs. It will be in 600 MB to somewhere around 800 MB size, smallest size of the image. So that image we can use and we can create multiple instances with no time, with less time, with one simple file we are going to use. So infrastructure as a code is making communication delays out. So that will sweeps out. That is the best example to tell about the lean methodology. From this lean methodology derived DevOps from the agile methodology. So the agility which you are going to get in the software development lifecycle It's a combination of iterative and incremental process. So you can keep on checking for a feedback. What is best we are going to get from the plan, get from the build process, get from the coding, get from the testing, get from the implementation or deployment process. Every area we are going to check for the what is the best, and we're going to get the feedback from every level. So that is a best thing which we are going to use, that is agile methodology. The process adaptability is very simple, and whenever you look for the delivery, it is so fast compared with any other method. So the customers will be first highest priority. Customer satisfaction is the first priority. The rapid delivery of the working software products. So you are going to have every requirement in a small pieces, and it will be incremental build. The market requirements, our customer requirements, our client requirements will be break down into small pieces, and that will be handled by different teams, so that the build process will be simplified, and these builds are provided in iterations. So you can test one particular scenario in your development area, then you can test in functional flow testing, then you can go with the uh, staging area, then you can push that one into the production. So these are the multiple areas, iterate the same test scenarios which we are going to have in the agile methodology. So agile is going to more spreading or more trending methodology in the current IT industry. So agility on the operations side, if you look at the administration side, now we are going to call operations. So where operation team were not able to match the speed of agile methodology to facilitate the provisioning of the servers. So the previous generation, people were DBAs and WebSphere administrators, WebLogic administrators, system administrators, Linux administrators. So all these are administration operations. They are having their own limitations towards that particular area only. Now, agile methodology is requires how we can make faster delivery, faster deployment, and fastly provision the services. That is what the requirement. So to turn up towards that or make yourself available towards that, we have this DevOps. Okay, that is a concept which will help you to understand how to make yourself uh, towards DevOps culture. Okay, any questions on these three different methodologies? Okay, if no questions, who introduced this term? Uh, DevOps, the word was introduced by the Patrick Debois. So he first time in 2009, Patrick Debois from the Belgium, and Andrew Clay is from the US, met and started talking about the kind of the term DevOps. So this word is started from this person, Patrick DeBoy. So he introduced this word, and there was a lot of conferences goes on in every area of the learning in the DevOps. So this culture is spread across all over, and you will see a lot of conferences, Docker conference, Ansible conference, if you look at Kubernetes conference, lot of conferences across multiple DevOps tools. Each tool is going to have one standardization from one common body, that is CNCF. We'll talk about that later. So that standard they are going to put, which is standard for the DevOps, which is open source. They are standardizing, which will be good for us. So why DevOps is so important? First thing is faster time to market. So fastest way you can develop, fastest way to resolve the issues, fastest way to deliver the service. And it will always look for the open source products, cheapest solutions always. So lower cost to deliver. If you look at the previous generation software development, always license cost huge, and they are dependent on the supporting systems. So no vendor lock. Some vendors, they are going to give so and so software, then we have to look for so logs, and all those things are gone. Those days are gone. Now everything is open source. Docker is open source, Kubernetes is open source, monitoring tools are open source. So higher quality and few bugs. So you can raise a bugs on the communities, and you can also contribute your learnings, your requirements in this open source software. There is multi-cloud culture coming up. If I'm having a product in Azure, the software should run in the AWS also. The software which we are going to develop, or the microservice products, should work same thing on the GCP also. So multi-cloud environments are upcoming in the current market. So that is supported by the DevOps. So that is one of the key factor where all software projects moving towards a DevOps culture. So if you look at this small table, so why DevOps? So you don't discover any new software defects, or you don't find until uh, end of the life cycle. This was a situation. If you look at the waterfall model, it should go on to 3 months life cycle. Then only you will be finding so and so bug in that particular uh, software. So unless until it will go to the production, you will find that particular issues. So that is not the situation here in DevOps. If you find some bug, immediately you will work on it. Immediately you fix it. Immediately it will go delivered to the production. That is what the DevOps culture. You use agile to speed up the development, but any gain operate once the apps goes into the production. So in the agile methodology, we are having the focus is like speed up the development. So whenever you are doing speed, it should not lose anything. So that is also we are going to have this agile methodologies with basic structure. They are going to have ticketing tools for every bug which you are going to work on. So there is a Jira ticketing tool, or there are a lot of options. So Jira is one of the best tool which will keep track of the issues or scenarios which we are going to work on. And whenever you work on one particular issue, you will assess who is going to work on it and how much time it will take, duration, and whenever it is completed, how much time is spent on that particular issue or that particular bug. So this will be easy to handle for the next time, for the next activity. So you develop test developers or testers who are working in previous projects, previous life cycle projects. They're constantly waiting to access the resources they need. There is a causing delays. For example, if you are going to take the previous waterfall model, if I want one particular Linux box, one particular machine requirement will be processed with approvals, manager approvals, then client approvals, then I'll get one machine. So developer or tester, they are going to send constantly sending mails and then looking into that when it is going to be completed. There is some systems, automated systems. Even then, that systems will not complete immediately. They are going to take some time to handle these requests, approvals requires, and delays are causing. So these delays and everything will be reduced in the DevOps culture. How? Using the containerization concept. So containers are very easy to use. You don't need to wait for the machine. You don't need to wait for the servers to access. So these activities are very easy to handle in the DevOps culture. So you cannot pinpoint problem across development, testing, production operations. So when something comes in, the problem can be anything, that may be application flow, or one page is not displaying, or 404 error, or some issue which is what you are going to get in the production, or you are getting at the development state or testing phase. You should not blame on any one particular person. So this is DevOps culture, where everyone equally ready to handle the problem or resolve the issue. That is culture, DevOps culture. So you see simple human errors whenever you see some of the process in the older lifecycle model, waterfall model. There are a couple of development issues or deployment issues which is actually taking, which are taking some issues towards errors. Or if you take some deployment process, you're having dependencies. For example, first I need to deploy the database connectivity related application, then only I can go with the web application. So this is a simple basic requirement in our lifecycle models, previous Java based applications. So this development requirements, if you miss the sequence, if I miss, first I started the web server, then if I start the database connecting application server, then I am getting errors in the application deployment process. It is always referring to so and so resource, and resource is not available. This is a human mistake. If you not follow a sequence, you will get the error. So this kind of situations will be handled with simple code. If you write in a YAML file, DevOps gives one simplest, easiest language, YAML, another yet another markup language. So this will keep on checking what is expected thing. You just define that one and it will follow that one. So you don't need to worry about what is the sequence, who did that step, what step missed it, all those things. Human errors, we don't need to worry about that. Development views their jobs as finished once the apps is into the production. Development previously they are in process. Once we complete our code, our program is completed, compiled, and ready, then they think our job is done. Now in DevOps, it is not like that. The DevOps, until it go to the production, it is working in the production also. They can keep on looking into that and how it is working. They directly have the access to the production. Previously, it was access limitations. Developer will have only development environment access. QA will have only QA testing environment access. And the production, only operations team or administrators going to have the access. So like that, it was distributed. Now there is no limitation in DevOps. DevOps team member, everyone can have equal importance and have the access to every application. It may be mobile application, it may be Java application, it may be connecting to the database. Anything you can access and verify value, what you have changed in your development, that it should be reflected. Anytime a problem arises, everyone start pinpointing fingers to blame on someone. In production, something goes wrong, database is not working, or network is not working, some other team will be looking into it. So always people looking into other teams' mistakes and saying that this is not our mistake. That was a scenario in the old waterfall model or the structure. So now in DevOps, everyone is equally part. There is no specific team, development team and operations teams all together one team. That's why there is no blame game will work. So that's why DevOps is so important in the latest trending, latest learnings. So DevOps all about infinity loop. So what is infinity loop? So whenever you start working, it's planning, then you're going to code it, build it, test it. This is development we are going to call. And on the operations side, release, deploy, operate, monitor. So this is operators who are worked earlier as an administrator. They are easily looked into the right side part. Who are worked in the development side, they will work into the left side part. So there is no limitation. Anyone can do any operations. So endless possibilities in this DevOps. Developer can monitor, developer can operate, developer can deploy. Or operator can code some changes, or they can look into that programs. They can change some SQL programs or Java programs. They can also change, they can also understand, plan, and test it. So this is the endless possibilities in the DevOps. You can create infinity loop in your development life cycle. So this is a complete system which you are going to always have a feedback at every level. All your code deployment targets will have the feedbacks. So based on the feedback, it is going to work better and better and better every time. So that is about DevOps infinity loop. So what is DevOps? DevOps is not a product, not in one single product. Earlier it was, if you are working on WebLogic, WebPeer, it is one product. Now this is not a product. DevOps is not a product. Or it is not a particular technology. This is one particular technology. It is works only on this particular platform, nothing like that. It will work on platforms which are non-cloud or which are on premises. It will work on cloud, which works on private cloud. It will work on public cloud. So there is no limitation for this particular technology. DevOps is a methodology that unites the often separate functions of software development who are going to develop, that is dev we are going to call, and the production and operations which you are going to deploy. You are going to monitor huge number of servers or services which you are going to have, that we are going to call as operations into a single integrated and continuous process. In DevOps, we focus on continuous delivery, continuous deployment, continuous integration. So this continuous word is very, very important area where we always look for that. So DevOps is about breaking down the barrier between the development and operations, dev and ops. It leverages the people, process, and technology to stimulate collaborations and innovations. You always look for the new betterments in every area. If you are working on one Docker structure or image, you always look for the better option for that, how to reduce the size, how to make the microservice much more faster. So that is entire software development and the release process will be focused here. And DevOps must act and feel like they are a single team. They are not two teams. They are completely single team. Okay. So that is about what is DevOps, and we have more points about DevOps here. So how this DevOps culture we are going to achieve? First, we need to think about how to optimize, how to make better in every area. Then we'll code. Every area we have to think about code, code, code. So there is nothing like we are not doing coding in any area in the DevOps. Every area we need to write something, and that will be very simple, easiest way reading. Code reading will be very, very simplest one. So YAML is the most common thing which will be used most of the areas. And programming, if you look at for operation side, Python is one of the best scripting language will be used. And when we are going to deliver these applications, we are going to deliver that with the highest speed, that is rocket speed we are expecting. Or the development team or DevOps team, they are going to deliver in a fastest way. That is the target. They run on any cloud. That is another area which is focused. It may be run on AWS. The same thing will be run on the Azure also. This is easy to manage. Something goes wrong, and another immediate alternative options will be looked readily available. That is very easy to manage. That is what expected from the DevOps. So learning curve should be always less. One person newly joins to your team, and you should have less time to work on your project. That means if a person joins today, tomorrow onwards he can start coding or work, understand that things in your project. So that is always you need to provide, you need to develop something culture, like when you fix something you have to give always comments in the code, and whenever you develop something new story, that should be create one page. Most of the projects they are using the Confluence pages. So Confluence is one of the DevOps tool which is commonly used. So all these are different areas which we can develop as a DevOps culture. So DevOps can be broadly achieved in the below 5 different phases. You are going to work with without fighting with each other, or development and operations or administrators are separate. So we are going to call everyone, each other is going to contributing to the project, and they are going to collaboratively developing the entire uh, project or the entire DevOps team. So continuous testing is one of the important area where every new feature, there are different three scenarios which we are going to test. So first thing is you're going to have some requirements from the client. That requirements will be tested. The second thing is you are going to get some issues when you are running one application. So issues will be fixed, bugs will be fixed, that will be tested. Enhancements, they are not from the development, they are not from the client or customer, they are not from the bugs. You are going to enhancing the features, so feature testing. So these are three different areas the testing team is looking for, continuous growing areas. So for doing all this, we need a continuous integration, continuous connectivity from every area. For example, I'm connecting to the database, Oracle database. So Oracle database is connecting to the application which is running on a Kubernetes Docker cluster. So that how it is going to integrate, how it so fastly can communicate, that we need to look for, and we have to deliver in that fashion. So continuous delivery, the code changes, whatever developer or development team working on, that should be delivered and deployed into the targeted environments. Okay, so whenever you look at different areas, environments, development team is going to have development environments, and testing teams, they are going to request for different scenarios or flows they want to test. QA team, so QA environments required. And once this QA is passed, then we are going to test on the performance level or staging level. So before going to the production, there is one more area environment which is going to have the more load test. So these are the different areas need to be delivered, and applications should be deployed in different environments. So that is continuously required to deliver it faster to the production. And the last one is continuous monitoring. So there is a lot of evolutions are happening in the monitoring area. Some monitoring systems, they are working with the time series. Some monitoring systems working with the logs. Some monitoring systems work only for the Java applications. Some monitoring systems work for the tracing of it, one particular transaction. So these are different areas. What is best suit for your application to monitor continuously? So if you look at the Prometheus, it is time series database. It's monitoring, continuously tracking what is happening to that particular application. And you can alert at any point of time when something goes wrong in that particular application, or if it is not responding from that particular URL, then immediately you can get alert. Alert will be triggered with the alert manager. Okay, you can monitor one dashboard. You can have 100 containers, and you can monitor all those with one simple screen. So that requires visualization, how you develop for so and so containers to monitor. So that is a continuous monitoring capability which we can do with Prometheus, Alert Manager, Grafana. These are the different tools, DevOps tools. Another stack came that is going to work with the logs, ELK stack, Elasticsearch, Logstash, and Kibana. It look into the logs. Logs will be considered as a document, and that will be breakdown with the time series and with the different instances from where it is collecting. And it is going to have the fastest way of searching capability. Elasticsearch is nothing but your Google search engine. It is directly using the same engine what you are having in Google. So Lucene is a search engine that will help you to look into the logs. You want to search for Oracle error, or you want to search for so and so exception, Java exception, here it is. So within fraction of seconds, you can find from the hundreds of logs, and you can get that output on the Kibana dashboard. So Kibana is a tool which will help you look into the logs. Kibana is a tool which will visualize, which will help you to understand the graphs, how many instances are up, how many instances are down. You can also track the system capabilities, how many cores, how many memory usage, how it is going on for one particular instance, one particular Java container, one particular cluster, or Kubernetes cluster, how it is working. So continuously you can monitor with the ELK stack, or you can go with the Prometheus, or you can go with the Nagios. That depends on the application, how your environment fit into. So you need to think in a broader way to think continuously monitor your application. Okay, so that is all about the 5 different phases which DevOps culture need. Okay, so collaborative development, continuous testing, continuous integration, and delivery deployments, then continuous monitoring. These are the areas. We are covering almost all of this, and we try to understand how the source code management will work. So in development phase, the collaborative development will work with the tools where the code will be stored, or source code will be stored distributed systems. The Git is the most common DevOps tool. So GitLab is a more advanced tool. There are so many wrapper softwares also coming on the Git. So Git is a distributed source code system. Previously, if you look at the source code system, you can store the code in SCM or CVS. These are the centralized systems. At one server, you are going to store. Now it will be distributed using the Git. So anyone can have the same equivalent code, and you can modify as per your enhancements or changes or bug fixes what you are doing on it. So agile methodology help you to work on your independent code changes, and it will not impact any others. And once your the story is successful, your code is successful, then you can push that code branch, you can merge. So that is a concept in Git. And Maven is a tool Previously, if you look at and it is going to take longer time in a Java application build, and it is also work for the C Sharp or .NET other applications. Maven is having more number of plugins. So first time, whenever you need something from the third-party systems, which are having the dependencies from the uh, third-party systems, that will be always loaded directly. And once it is loaded, those plugins, you can simply use the Maven. Next time onward, you don't need to load. So it will be fastest way to compile, build, and then create the deployment units. We can create jars, vars in the Java programming. Same way, you can also work with the Maven plugins for the .NET, C Sharp, or Android and iPhone apps. So it is very simple and easy to use. And latest some more new tools also coming in the compilation build tools are coming up. Okay, so this is one area where collaborative development will work. So after developing, immediate phase is continuous testing. So DevOps cannot be realized without continuous testing. So if you are delivering 10 different bugs or 10 relevant Jira bugs or issues which you are going to work on, and that 10 issues should be tested continuously with zero intervention. And people are looking for the automation at every area. So testing also, they need immediate test, fastest output. So there are a lot of types of tests in continuous testing. Smoke test, regression test, acceptance test. So all these areas are going towards with DevOps culture. So they want to make this happen with small coding so that they can test whatever the area, whatever the flow they want to test, whatever the pressure they want to test on that particular flow, regression test, and what is acceptable scenario that is defined by the DevOps tester, DevOps QA person. So execution process, which will be accomplished through automation of testing. So for this one, we are having a lot of tools, different frameworks. That is another complete area, new area where people are keep on working on that continuous testing. Okay. Now, till this, you have any questions? Okay. So after the continuous testing, we'll move towards the continuous integration area. So people work on the planning and coding and deployment. After that, they are going for the testing. Once the test is successful, then we are going to integrate with the different other systems. So once continuous integration is practiced, it is going to be shared across. Once that is successful, design, build, test is successful, then what we are going to do, we are making one pack, that is Docker image. This image will be shared. This image will be placed in one common area so that every other teams can use that one. Or multiple testing teams are there, they are going to use that. So to store that Docker images, we are having one common storage location. Some people are using JFrog to store images. Some projects are using SonarQube. So that depends on the size of the images, that depends on the space and flexibility they want to use. So integration part, where we are going to packing the artifacts, the packing of your code successfully compiled or tested. That one we are going to make available for everyone. So continuous integration is a practice of checking in code, checking into the Git to a shared repository. You can check in the entire image, that we can use the Sonar Cube, or we can use JFrog, Artifactory. So these are all different several options we have, and every time we are going to do some changes, it should not impact, it should not affect other person's accessibility. So if I'm going to use one image 1.0, and that will be accessed, that will be packed and pushed into that particular artifactory, other person can use that. So if I'm working on another feature, tonight I'm going to give another version 1.10. So that could handle that one. The repositories are capable to maintain historical data, so that people can easily access, and they can we can work on multiple times, several times in a day. We can store, we can retrieve, push and pull the images. Okay, that way you can have access, and you can also work, you can also detect problems early and fix them whenever they are earliest, as early as possible. We can fix the issues in a different areas, because they are delivered to the different integration teams. Okay, so new features always welcome, and they are developed, they are used by the users, and as early as possible we are going to work on the issues, features. That will be easiest way if you are going to have continuous integration in place. So DevOps always look for the third phase as a continuous integration. Okay, so that is about continuous integration. Continuous delivery, continuous deployment. So it's a series of practice that designed to ensure the code can be rapidly developed and safely deployed to the production. So the end goal is it should go to the production. When you are delivering every change to your production like environment, and ensuring the business application and services, the function as expected. The whatever the function you are changing, it should be rigorously tested, and it will be tested automatically. So that is expected. That is done by Selenium or different frameworks they are having. So JUnit or load test tools are there. So these are all help us to continuously test it. After testing, the every change, that is going to be proved as a okay or not okay. So once that is done, then that will be delivered to the staging environment. So once this staging environment is completed, staging with the load test or performance test, you can have the confidence so that the application can be deployed to the production. So once it is pushed to the production and the business ready state, that is ready to use in that particular business. So it is primary goal, its primary goal is enable the automated deployment and production ready application for which you are going to make it. It is always in every DevOps person goal. So sometimes you continuously modifying changes, deploying for continuous delivery, continuous deployment. It will be looks similar, but it is not similar. It's a different. Continuous deployment usually refers to the production deployments. Continuous deployment is targeted to the production. Continuous delivery is how many times you change code and you can send to test QA side. So that is a continuous delivery. So again, I'll show one flow so that you can understand what is the difference between continuous delivery and continuous deployment. So this picture, you're going to have a unit test, platform test, and in between there is automatic process. So once test is completed, automatically it will go to the next phase. So deliver it to the staging, then application acceptance test, then it will go to the deploy to the production. So this part, manual from the user acceptance test to the deployment to the production. After deploying to the production, again we'll do testing, the post deployment test. So this is continuous delivery process. This is what preferable option. If you look at the continuous deployment, the unit test, platform test, everything, all are automated. Even in production also, from the user acceptance test to the deployment to the production. Nobody, no manual intervention. Nobody looking at those things. Then it is continuous deployment. This is not a preferable option, but yeah, this is also possible to work on in a DevOps. So continuous delivery, continuous deployment. Only one phase is not automated, that is going towards the production. Okay, so there are business cases in which IT must wait till it go to the management decisions, then only it will go to the live. So that is what make the comfortability. So continuous delivery is in most of the places. Okay, continuous deployment is right for the some of the projects which does not require any manual intervention. Some of the features like e-commerce applications where what product is going onto the display, what inventory is updating. So these kind of scenarios, different scenarios, it will be break down into that one, and then those things, those flows can go into the continuous deployment. So that depends on the how you are going to limit, how the business needs matches to this continuous delivery and continuous deployment. Okay. So DevOps lifecycle looks like this. It will works from the plan, code, build, test, release, deploy, operate. So these are the different phases overall. So each phase is having. So if you look at the first plan, code, build, test, release, till this one is continuous delivery, and continuous integration. You are going to work till the testing part, that is called continuous integration. Agile development method is planning, coding, building process. So whatever you work towards till the all the phases, that is collaborative work, and DevOps is going to deal with the plan, code, build, test, and release, deploy, operate. Every phase is included in the DevOps. So continuous monitoring, that is after going to the production, that is operations phase. So this is the last phase of the DevOps. Okay, so once you complete all these phases, once you develop the application, once you integrate the application, once you deliver that one, then we are going to do continuous monitoring. So this is complete application where you are going to have the continuous monitoring capabilities required by the DevOps. So the final life cycle phase is the monitoring phase for every application that goes to the live. Okay, so these are the different phases we have in DevOps. DevOps tools, there are a lot of tools keep on coming up, but we are just looking at the limitation of our course, that is DevOps Foundation. So in this course, we are going to touch up few of them, and few of them are ignoring. So Git, SVN, if you look at this, these are different areas which you are going to store the code, or you can manage the software. So source code management is one of the tools which you can use. So distributed source code management is Git. Git we are going to learn first phase. After that, compilation process, we look for the some of the tools. One of the tool is Maven, that is the best suitable for the Java applications. And then testing part, JUnit, SE, that is Selenium. These are the areas which DevOps is looking for. So all these are comes into the uh, agile methodology. Then moving towards continuous integration. This is a heart of your DevOps tool, and it is basically integrate operators and development teams. So Jenkins is automation tool which will help the code will be deployed towards the targeted environments. So deployment process, we can work with the different configuration management tools, Puppet, Chef, Saltac, Ansible. So what state need to be done, what is expected thing from the environment, from that particular environment, we can tell with the definitive languages. So all these tools, configuration management tools, allows us to define what state expected. So Ansible is a push Ansible and Saltop. These are the tools based on the push technology. And Puppet and Chef, they are going to have the agents at different levels and the remote machines. So they are helpful. They are also works in the same fashion how Ansible Saltop works. So configuration management will help us to make the application available continuously. Okay, so some small learnings with the YAML, small pieces of understanding about the system availability state of the systems we need to understand so that we can develop the continuous deployment process. So in our case, we are going to learn Ansible in one of the configuration management tools. The next one is operate, where you work on different CLI. So most of the time you are working on the Linux system. That is where you are going to operate. And monitoring, as I talked about, different options are coming up, keep on growing in CNCF model, Prometheus or Nagios and the Realme New Relic and Sensu. These are all different tools which are already working on different platforms. It may be cloud platform, it may be non-cloud platform. It works. So monitoring concept is based on the how you are going to handle, how you are going to monitor the entire system in production. That is focused in one direction, and how you are working on the non-production system. That will be in another action area. So these are all areas which we are going to learn as part of DevOps tools. So if you look at DevOps, it's growing continuously. Hundreds of open source tools are coming up. Hundreds of application supporting tools are also coming up. The Microsoft is coming with the different tools. CNCF is coming with the different tools. Linux Foundation is coming with the different tools, different monitoring tools, different uh, coding capabilities also coming with the JavaScript, Java, .NET. These are all different areas. They are coming with the smallest size of application. They want to reduce, optimize the code. Every area they are looking for that process. If you develop something for monitoring, today we are developed and we are able to monitor, and tomorrow we want to make better of that option. So each one is developing, expanding with a lot of new tools and lot of optimized methods. Okay, so DevOps is a infinity options with a lot of tools coming up. So don't worry, most of the common tools which we are going to see, that is five different tools we are looking at, and five basic phases we cover in our foundation course. So what is not DevOps? This is makes you much more clarity so that you can look into the further. So DevOps is not a unholy union of development and operations. So people are thinking, I was in Java coding, how can I go into the administration works or operations works? Our operations team guy will think about, I never did a code, I never write a Java program, how can I work in that? code changes. So it is not that one specific tool, or if it is not, if you look at the concept, it is a culture. How you develop in your project, that is just a culture. It is not mandatory. You have to work only this area, only that area. There is nothing like that. So you can work and make a success for your project. That is what focus. So DevOps is only exist in cloud. Is it? No. DevOps can work on non-cloud platforms also. DevOps can be anything which will work faster delivery or whatever the 5 pages we talked. That is DevOps. DevOps is a single product? No, it is not one product. Just now we have seen on the screen hundreds of tools are coming up. They are tools. They are not any product. DevOps is not a product at all. DevOps is a culture. DevOps is a culture. DevOps is a learning methodology or software development methodology. DevOps is not a myth. It is not something like this and that. There is no specific rules. Only thing is you need to make optimistic code delivery, optimistic productivity. We want to bring it up. Agile methodology is a part of this one, and DevOps does not mean that developers are responsible for operations or operators are responsible for development. Nothing like that. So there is no specific changes, but it is always mixing up. Anyone can do anything. That is what the main goal of DevOps. So DevOps does not mean that governance. This is like nobody is looking for the management, or nobody look for the lead, or nobody is something who are leading the team. That is not the thing. So there is always different Scrum teams working on DevOps culture, and there is a compliance. There will be a connectivity between one phase to another phase, and we are going to have a delivery process. So anyone can take up, and we can follow that delivery process. You can define one process, you can use it, and you can uh, work on that. So DevOps is, it doesn't mean one governance or compliance, one particular compliance only we have to follow, or one particular scanning only need to be done. This is not limiting. It will be unlimited. Anyone can use any tool, any program to develop that action. So any task can be taken by anyone, and nobody will be forced to take anything. So it will be reduces the load on the team members to give more happiest culture. That is what the main theme of this DevOps. Okay. So what is the scope of this DevOps? DevOps, it is not a software, it is a methodology, and which will adopt sooner or later. So how many people are into this DevOps? Around most of the IT industry, software industry is moving towards DevOps culture. Around 40% are moved towards this. And all of cloud-based applications, the applications which are into the cloud, they 100% go with the DevOps team. And right now, cloud is a leading technology. Cloud technology is leading technology. So cloud needs DevOps engineers, DevOps architects, DevOps QA, SREs. So DevOps is going to be de facto standard for the software development lifecycle. It is going to give knowledge on complete infrastructure, how many servers, what type of servers, all this are gone. Everything is containerization. So now development team aware of that, how it is going to work in production. And they also realize that how it could serve many customers. Whereas operators who are working on the administration area, they also understand how the development team works on the code or develop the code, resolve the issues. So early advantage in the DevOps can helpful to grow faster in the industry. If you understand DevOps how it works, then you can grow faster. Every phase, the 5 phases what I talked, that if you understand, then you can build complete end-to-end application in DevOps. So how much you touch up with every area that will help you to grow faster in the DevOps teams. So higher earnings is 100% guaranteed. The people who are working in longer administration jobs, they are once they have turned to the DevOps engineer, they are getting very good pay packages with this. So this is a scope about the DevOps. Any questions? So this is a trend going on in 2020. Lot of technical trends. People are coming up with the different statistics. So DevOps is a compulsory learning area, and it will be continued till another decade. And parallelly, there is artificial intelligence and machine learning and a lot of other tools also coming up, and we can also keep growing with these technologies. Okay, so any other questions before we'll stop? No. So these are the questions. Is DevOps is only for cloud? No. DevOps can be non-cloud platforms also it supports. Is DevOps related to the cloud computing? DevOps is adopted with the DevOps. DevOps is used by the cloud. Every cloud they need DevOps. DevOps engineer, DevOps culture is required. So how is DevOps different from the traditional IT? So DevOps is not working with the SDLC concept. It is working with the agile methodology. It is always focused on the lean methodology. It is always look for the smallest service or unnecessary features will be removed or cleaned up or deleted. So that is the major focus. Is DevOps better than Agile? Agile is one of the part of DevOps. So you have seen the development process is in DevOps. So Agile is 3 phases covered that we are going to call as Agile. Thus, DevOps replaces Agile. Agile is only first 3 phases, and it is not going to replace. It is a part of DevOps. Are DevOps engineers in demand? Absolutely. It is absolutely a growing area. If you look at LinkedIn, if you look at Naukri and search for DevOps engineer, you will be getting more and more number count compared with any other previous job. What does DevOps engineer do? The whatever 5 phases we talk, that 5 phases we are going to work. So DevOps engineer work in a 3 different areas. We are going to work in development area. We are working on the testing area. We are working on the production operations area. That depends on the how much experience in that particular project. So there is a terminology coming from the Google published page, site reliability engineers. So that is another area where the DevOps engineers can enhance their skills towards the monitoring capabilities. Once you learn the DevOps, they can move on to the SRE roles. That is the most important, a critical area in the DevOps engineering area. The DevOps needs coding. It is not 100%, but definitely we need to code. Coding is always helps to make automate faster. Delivery will be faster. So any area which you are looking at, for example, you are working on the server configuration. So the server installation configuration takes manual action for one particular machine, it takes, let's say, 4 hours. If you do everything with automation, it will take 5 minutes. So that process you need to understand and develop. So all those steps which you are doing manually first time, you collect all of them and put into the script or put into a code that will help to faster delivery, faster configuration, faster installation process. So these basic, simple, small size coding is must in DevOps. It is not mandatory, but you have to make as a practice. So I hope all of almost all questions are covered in this questionnaire. If you have still questions, please unmute and you can ask. Thank you, guys. Um, please follow us on Facebook
Hello.
and YouTube and Twitter. So if you have any questions, please talk to Shailja for this course. So we are about to start this course as soon as possible and with same morning timing. As expected, 35 hours is a course duration and it would be morning 7 o'clock. So please sign up for your information. Please talk to Shailja. There is a question from Colleen, how course helpful to the DBA. There is future definitely help all the operation guys, DBA, system administrators, everyone are moving towards DevOps engineers. So this will absolutely gives you the life for the operations guys. So
Sir.
definitely it will enhance your skill or upgrade your skills. So it will helpful for you definitely. And it will easy help for your grabbing a new job. Yeah, so one more important thing, it is too much theory for today, I think. Yeah. So what I would like to yeah.
Pawan sir, can you hear me?
So as I talked about the lab setup, we can create our own lab on our system. So I have one set of options like you need to download the two things. One is Vagrant. Vagrant, based on your operating system, please download Vagrant. If you are, I'm working on Windows machine, so I'm going to choose this one. Windows 64-bit Vagrant. Okay. The second software which will help you to create the virtual box, that is virtual box download. So this is Oracle virtual box. So this will make you help you to create the Linux, okay, Linux box on your Windows system. You can switch between that and you can create. So you are working on Windows machine, so Windows host you select and you can download this. So you just click and you will get the latest version of Oracle virtual box. So please install these two to attend the next session to work with the practical things.
Hello, can you hear me, Pawan?
Any other questions?
Can you hear me? Hello. Hello.
So I will stop here today's session. So you have any questions, you can WhatsApp send your questions to Shailaja so that we can proceed further and we can talk about this course. Thank you guys. Thank you very much.
Hello, Pawan.
Hello. Yeah, please tell me. Hello.